Hey guys, this is our lesson for using the standard algorithm to add and subtract decimals. Today we are going to fluently add and subtract multi-digit decimals using the standard algorithm for each operation. In this specific lesson, we'll be using a place value chart to organize our computation. Okay, we're going to go ahead and skip that start problem here, and we're just going to go right into the lesson. It says, how much greater is the mass of a dollar coin than the combined masses of a dime and a quarter? Okay, so there's two things I need to listen to in this problem. I see that I have combined masses. So when I think about the word combined, what does that mean to me? What operation am I going to use to find a combined mass? And then the second thing I want to be thinking about is how much greater. So I'm finding a difference. Okay, so I'm thinking about what operator am I using there? Okay. So let's go ahead and look at the first part here. I can't find the difference between two things if I don't know what the number actually is. So it says the mass of a dollar coin, blah, 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 combined masses of a dime and a quarter. So what we're going to do is we're going to go ahead and add the dime and the quarter together. So I'm just going to use my place value chart to fill in my numbers here. And then we have a quarter, which is 5.67. And then here, where you see this blank spot, you're welcome to put in a 0, or you can leave it blank. Okay, and then we're just going to do our addition. I like to make an addition sign here so I know what I'm doing. So 8, 6 plus 7 is 13. I record my 1 on the total bar. 2 plus 6 is 8, plus 1 is 9. Bring down my decimal, and 5 plus 2 is 7. Okay, so now we know that the combined weight is going to be 7.938. And then now we need to find the difference. So it's asking us how much greater, how much bigger is that dollar coin than the combined mass of these two. So I'm going to start with 8.1. That's my quarter mass. And I'll go ahead and fill in those empty spots there with a 0. And then we're going to just use this combined mass right underneath. So we'll be subtracting 7.938. Okay. We are subtracting across zeros here, and I can see that 1 minus 9 is not going to work. So I'm actually going to be doing some borrowing all the way from this, this side of the place value chart. So when I am borrowing or regrouping, I like to write the new number on top rather than just tacking it onto the side. So then since I borrowed 10 ones here, or 10 tenths, to make one whole, I'm going to put it over here. So now this is no longer 1, but it'll be 11. But we're going to borrow for the next one. So this becomes 10. And this one becomes 10. But then I'm noticing that I need to borrow again one more time. So this now becomes 9. And this is a 10. So now that I've done all of my regrouping, I can just go ahead and subtract. So 10 minus 8 is 2. 9 minus 3 is 6. 10 minus 9 is 1. Bring down my decimal point. 7 minus 7 is 0. So our answer, we know that the mass of a dollar coin is 0.162 grams larger than the combined mass of a dime and a quarter. Looking at number 2 here, it says that Abram makes a mistake when he finds 8.196 minus 2.4. Describe his mistake and show the correct subtraction. So there's two things that we have to do here. We have to describe the mistake that they did and then show the correct subtraction. So when I have an error analysis problem, I'm looking for the mistake, and then I'm going to show with my work how to do it correctly. So I'm just going to rewrite the problem. So I know that the problem is up here, and when I'm adding and subtracting with decimals, I need to keep my decimal points lined up. That's where that place value chart comes in, but for now we're just going to go ahead and we'll write it out just freehand here, leaving a little space in between each number, and then we have 2.4, and then I can see here that I'm missing some spaces. You can leave that blank, or you can fill it in with zeros. So this is our work. compared with Abram's. So I can see here we have this part is the same, but then when I look down here, Abram has 2.004. And I can see he made a mistake that when he was lining up the place values, he put a 0 and the 4 over here in the thousandths place. So clearly we can see what his mistake was, is that he shifted it over a couple place values. So now that we've seen that, we can go ahead and just do our subtraction. Okay, so 6 minus 0 is 6, 9 minus 0 is 9. 1 minus 4 we cannot do, so we can regroup. This becomes 7 ones, and this becomes 11 tenths. 11 minus 4 is 7. Bring down our decimals. 7 minus 2 is 5. So we can see our difference in answers here. This one is the correct answer, and Abram's mistake. All right, looking at number 3, we have an algebraic expression here. I apologize, you guys. Peso is on his cat tree behind me going crazy for a little toy. All right, we're going to substitute wherever I see an M, I'm going to put the given value right here. So really what we're working with is 15.45 minus 7.432. And normally when I'm reading decimals, we want to read it with the thousands and tenths and hundredths. I apologize for not modeling that. I will be better next time. All right, I'm just going to stay consistent in this video. Okay, here we go. We're going to go ahead and put our numbers in here. So we have 15.45, okay, 45 hundredths. So what we would do when we're reading it is we have 45, where it ends in the place value is where it'll use that, so 45 hundredths, okay, minus 7.432. So if we're putting it in our place value, we have 7.432. And if you can see here, we have a 0, we have a place missing here, so we can just go ahead and put a 0 in its place. Okay, so it's 7.432, or 7 and 432 thousandths. Okay, well, let's go ahead and subtract. I'm going to make my subtraction symbol red, and I'm going to put it over here so it stands out. And let's go ahead and look to see, we need to do a little bit of regrouping here. So this becomes 4, this becomes 10. Okay, so 10 minus 2 is 8, 4 minus 3 is 1, 4 minus 4 is 0. Bring down our decimal. Now over here, we could regroup, but I'm looking at some whole numbers here. And really this is just 15 minus 7. So I could borrow from here, but then it would still make it just 15. So I can just say 15 minus 7. Okay, so 15 minus 7, I know, is 8. So our answer here, 8.018, or 8 and 18 thousandths. Okay, number 4. A city receives 0.063 meters of rain in April and 0.15 meter of rain in May. What's the total amount of rain the city receives for both months? Show your work. So when we're looking at this problem, it says, what's the total amount? So that's asking me if I were to combine May and April. So that tells me that I'm going to be using addition for this problem. So all I'm going to do here is I'm going to take these totals, and then I'm going to put them in my place value chart and add them together. Okay, so for April, we have 0.063. For May, we have 0.15. And we'll go ahead and fill that in with a 0 and just go ahead and do our adding. 3 plus 0 is 3. 6 plus 5 is 11. Now, when I'm adding, I like to carry over at the total bar again. 1 plus 1 is 2. Bring down our decimal. And we can say that the combined rain total is 0.213 meters. All right. So for this lesson, really what we're trying to do is we're trying to fluently add using the place value chart to help us keep our numbers organized so they're not squashy and running into each other. So be sure to use your place value chart. And if you're not, then like we did with the Abram problem, making sure that we're lining up our place values nice and straight and giving enough room in between each number, each digit, so that we can see which place value we're in.